Good afternoon, colleagues. It's going to be our first lecture about Python programming language. And maybe let's start with the official page of this language. You can see that official site has name python.org, and here you can find all necessary things for starting Python programming. For the first, here you can find a download section, and here it's possible to download the latest version of a Python interpreter for your particular operation system. Also, here is a documentation part. By the way, now the current, maybe latest version is 3.10.2, and maybe it makes sense to use this version because in this version we introduce some new interesting control flow constructions which we can't use in previous versions of this language. Also, here is a documentation section, and there are a lot of useful things here. For example, you can find beginner's guide, also something which has name PEP index. By the way, let's take a look at this PEP index. Let's try to understand what is PEP. Actually, PEP it's a acronym for something like Python enhancement proposals. What are Python enhancement proposals? Actually, you know that Python is a language which is developed by community, and each time when someone in a community has some new ideas how he can improve the language, he creates such document which has name something like PEP, and then the number of the PEP. So here we can find all PEPs which are created, and now some of them are rejected, some of them are approved. And by the way, maybe if you have some questions about why something, some particular things are created in Python in some particular way, you can find the answer to this to all of these questions actually here. Also, some of PEPs are really important for us. For example, we can take a look at PEP with number 8. Actually, this is a style guide for Python code. You know maybe that all modern programming languages have something like code conventions. Maybe you know about Java code conventions, also for C++. There are a lot of different conventions, and we can follow one of them. Why these conventions are important? There were some research, and this research show that usually the performance of developers, in this case I mean performance of developers, not performance of our program which we are going to write. The performance of developers depend on style how code is formatted, and actually it's not important how code is formatted in this case, but what is important, it's important that all your teammates should use the same code formatting. All of them should use the same naming conventions, the same conventions about placing parentheses, brackets, and so on. So for some languages we just should create such conventions for some particular projects. For example, in C++, we don't have conventions which are used by the whole community of C++ developers. But in other languages like Python or Java, we have conventions which are used by all community members. So PEP8, actually, this is a document which defines such conventions for Python. And maybe if you want to write code which will be understandable for all other members of Python community, it makes sense to read this document and then follow the rules which are described here. So this can help us to make our code maybe more supportable, more understandable, more readable, and so on. So here you can see a lot of examples how we should write code, how we should use something like parentheses, operators, blank lines, and so on. So I can recommend you to read this document before starting. Also, another very useful part of Python official site is Python package index, something like PyPy. Here you can find a lot of projects, a lot of libraries, third-party packages which can be used for solving different tasks. Each time when we want to work with databases, maybe with some web development tools, maybe with data science tasks, each time we need some external packages, and we can find them actually here in Python package index. You can see that here are 300,000 with a half the total number of projects which are located here. So there are a lot of projects on PyPy, and all well-known popular libraries can be downloaded from here. Python provides a tool which has name pip. Later we are going to discuss this tool, and I'm going to show you how to use this tool for installing some particular packages. So if you want to sorry please, if you want to install new third-party packages, you can do that using pip from this Python package index. Maybe that's all about official page, and then maybe let's start to do something with Python. What is interesting here, Python actually it's a interpreting language, and this allows us to write our command and immediately run them and see the result of command execution. Actually, this is very convenient, especially for some particular cases. For example, for solving machine learning and data science tasks. When we do something with machine learning and data science, usually we work with some maybe even raw data sets, and we don't have some exact knowledge of what we are going to do with this data. And in such cases, we just want to give some instructions to our interpreter and see if our code works or not, and then we can choose a correct algorithm to doing something with our data. So for such case, maybe the most convenient way to work with data, actually it's a using of interpreter, in using interactive mode, in which we can give a command and immediately get the result. So if we are going to interact with Python, we can just run shell. In my case, I'm going to use Linux operation system, and I also recommend you to use Linux operation system for working with Python. Significantly simpler to install packages and work with Python if you use Linux. So in this case, I just want to write my Python interpreter from command line. I can just write Python 3, and then you can see that Python 3 is executed. Now we can see a prompt, and here we can give some particular command which we are going to execute. Let's start with maybe the most well-known popular program which we usually write when we start to learn new programming language. This is a program which types or prints something like "Hello World." Let's do that. In Python, it's now just to write print, then parentheses, then quotes, and then hello world, then maybe exclamation mark if we want, quotes, and then we can close parentheses. Let's press enter, and we can see the result. As I said before, you can see that Python executes command and immediately prints the result here. So we can say that our command works, but it's just an instruction. It's not a program. This is one instruction, and if we want to repeat this process, we should type our command again. If we want to write program, we need a little bit more. In this case, we should use something which we call text editor. In this case, there are a lot of different text editors which can be used here. What I want to actually, you can use anything which you have, but if you use Windows, I just want to tell you that please don't use Notepad, because Notepad has a lot of issues with writing programs. So in my case on Linux, I have something which has named gedit, and it works good for my purposes. In this case, I can just write here actually the same instruction: print, then parentheses, hello world, maybe without comma, world, then exclamation mark, quotes, parentheses, and that's all. Then I'm going to save my program with some particular name. It can be something like hello.py. Py, it's a standard name for standard extension for Python programs. And then let's go to command line. Let's exit from Python shell to system shell, and then type something like Python 3 space and the name of our program hello.py. Let's press enter, and you can see that it prints hello world. But what is the difference between separate instructions which we can run in Python shell and a program in this case? The difference is that we can run our program again and again, and we can see our results each time when we run our program. So if we want to repeat our process more than once, then we can just create a file, write a program, and then run it actually more than once. So this is a way how we can run our programs from command line, but for our course, for our lectures, I'm going to use a little bit different approach. I'm going to use development environment which has name Jupyter Notebook. This environment is very popular in Python world. It is used for machine learning tasks, for data science, and so on. And actually, it's very convenient to use this development environment for learning, because we can just store the session, and then I can share the session with you, and you can repeat all steps. You can change something and try how it works and so on. So there are a lot of benefits of using Jupyter Notebooks for learning. But because I'm going to use Jupyter Notebook, and actually Jupyter Notebook, it's a third-party package, I should install it. How to do that? In this case, I'm going to create new virtual environment for my for my lecture, and then use it each time when I'm going to record new video for this course. I'm going to create new environment. For now, maybe it's a bit difficult to understand what I'm going to do, but later we are going to discuss all of these steps. So now you can just see how I do that. Later I'm going to explain all steps which I do. So in this case, I'm going to create new directory. It's going to be something like Python, maybe 22.0.207. Just a date. I use it to separate this folder from other folders. So let's go to Python. And then I'm going to create new virtual environment. Modern Python supports a creation of environments from modules of standard library -m-vn. This is a module which creates new environment, and then the name for environment is going to be env. Let's wait a minute while environment is going to be deployed, and then we just need to activate this environment, something like source env being activate, and then run something like pip install Jupyter package, and then let's wait. Let's wait a minute. You can see that pip automatically downloads some additional modules. Some of them are already cached in my case because I use Jupyter Notebook very often, so I have a lot of packages. I used a lot of packages before, and now Jupyter Notebook is installed. So I can just write Jupyter Notebook and run the notebook. So now notebook works, and let me tell a few words about this environment. Let me explain how it works. We can use Jupyter Notebook for some on our beginning stage of loading. We are going to use Jupyter Notebook because, as I said before, it has a lot of benefits for that. So when we run Jupyter Notebook, we can see such window. It's a online tool. It works with. It can be online tool. Yes, it works with browser, and we can see this web page where Jupyter Notebook shows current state of our current folder, of the folder from where notebook is started. Then here we also have new button. We can press it and start new kernel. This kernel allows us to write some code here, and then we can just run this code and immediately see the result. Absolutely the same as in regular Python shell. So what I'm going to do, I'm going to write something like print, then hello world. If I want to run this command, I can just press run button or just press Ctrl Enter. You can see that this command is executed, hello world is printed, and after using or after running all commands which we need, we can just save this session as ipynb file, and later you can open it again and see all examples and run all examples which we considered before. Okay. So hello world is printed, and we can see that we can continue to work with Python. Let me repeat that it works in the same way as Jupyter Notebook runs commands in the same way as we do that in a regular Python shell. So now let's start to discuss the language syntax of the language, and maybe let's start with data types, with constants which can be represented in Python, and let's discuss different data types which can be used in this language. Python it's a high-level language. It uses high level of abstraction, and as a result, it has some, I can say, very simple set of data types. We don't have some differences like maybe like in C or maybe Java, something like integer values, then long integer, then short integers, and so on. In Python, we don't need to know about that because it's a high-level language, and usually we just can think in maybe more high-level abstractions like just integer value or float point number or maybe a Boolean value and so on. So as a result, Python has very small set of built-in numeric types, and maybe let's start with these numeric types. Actually, Python implements four basic numeric types, and the first type it's a Boolean type. It has two constants, true and false. By the way, in this case, I just typed true and then executed this cell. What Python does in this case, it considers this constant as an expression, and then it tries to calculate this expression. Actually, true equals true, so in this case, Python just returns true and prints it as a result. Okay, so we have a constant true, then we also have a constant false, and then the data type has name bool. Python provides a function with name type. It's a built-in function, and we can call type and see what is going to be the data type for this particular value. True has type bool. And I said before that bool is a numeric type. Yes. What is the reason why I said that bool is numeric type? I can prove that. Bool is numeric. We can write something like true plus true, and you can see that the result is 2. It means that true equals 1. And really, in Python, true and false are just integer values, 1 and 0, and Python provides just add aliases, something like true and false, to make our code more readable when we work with Boolean values. What we can do with these Boolean values? We can use traditional logic operators like logical AND, logical OR, and logical NOT, logical inversion. We can how they work as in any other languages. I hope you know how logical operations work in other languages, so let's just see the syntax. So we can write true and false. It's going to be logical AND. Then we can write write something like true or false. It's going to be logical OR. And also we can use Boolean or logical inversion. We can do this in such way, just not true. The result is false. We should know that and OR are calculated by short circuit algorithm. You know maybe what is that. You know that when we use a logical and first argument of our operator is false, a result is always false. Yes, and in this case it doesn't make sense to calculate the second part because result is going to be false. And the same with OR and true. If the first value is true, result always is true. As a result, we can just skip the calculation of the second part, and as a result, we can a little bit improve performance in some particular cases. Again, I can prove that. We can see that it really works. For example, I can try to divide something by 0, and you know that it's impossible. Yes, in this case, our interpreter tells us that we have 0 division error. But if I write something like maybe 2 less than 3, which is true, and then or 5 divided by 0, we can see that a result is true. What it means actually? It doesn't mean that I can divide by 0. Yes, it means just that Python calculates in this case the first operand. First operand is true, so interpreter can say that the whole result of this value is going to be also true. And it's not necessary to calculate the second expression in this case. So it's some kind of optimization which is used in Python and in a lot of other languages. Okay. So here's an example how how these operators in Python work. Then maybe that's all about Boolean data type actually, because we don't have any other options for working with Boolean values. So let's go on. This is the first data type, numeric data type in Python. The next is integer data type, and let's see how it works. We can just write type and then some particular set of digits. We can see that this value has type integer. What is the first maybe and the most significant difference between integers in Python and integers in other languages? The difference is that in Python integers don't have any limits. You can see I typed very large integer, a lot of value digits 9, and then I want to add 1, and you can see that it works and it returns correct result. So we don't have any overflows or something like that. It means that Python can work with very large numbers without any additional without installing or importing any additional packages or modules or something like that. So Python integers don't have limits. Yes, maybe we have some physical limits. Maybe we can say that if we exceed accessible random access memory, in this case we will have some memory errors, but maybe more real life examples we usually don't have any limits. Integer numbers can contain a lot of digits. What we can do with integers, actually we can use any possible standard arithmetic operators like addition, multiplication, maybe subtraction, and so on. Actually it works. What about division? We have one difference between Python and other languages. You know maybe that in other languages traditionally in programming, if we for example divide integer by integer, the result is going to be also integer, yes, but in Python 3 this behavior is changed. So if we divide 5 by 2, the result is something like 2.5. so this value has another type. Actually it's a float number. And why in this case Python returns float number? just because Python developers decided to make language maybe more expectable for anyone who doesn't have any experience with programming. So in this case, we will not have some unexpected errors in calculations because division returns integers. If we really want to have integer result, we can use double slash. This double slash means integer division. Also, there is a modulo operator, or operator which returns reminder. We also can use it in our arithmetic expressions. And it's possible to raise some integer value in a power using this construction. Maybe that's all about arithmetic operators. Also, Python has a set of bitwise operators, something like bitwise OR, bitwise AND. Where is this? I'm sorry. Yeah, I'm sorry. Let's try again. 2 and 3, something like that. It's bitwise AND. Then we also have exclusive OR, and also we can use binary inversion. So bitwise operators, I hope you know how they work. All of them also implemented in other languages like Java or C++. And actually, you know that Python is written in C, Python's interpreter, so this interpreter is written in C. And as a result, a lot of language constructions are inherited from C. You can see that all bitwise operators use the same syntax as in C language, yes? Also, we can do shifts. Maybe it will be a little bit more interesting, something like that. Yes, this is a shift to right, and then we can do shift to left. It's also bitwise shifts. And maybe that's all what we can do with integers. Then it's possible to compare integers using comparison operators, something like equals. To say not equals, we can do something like that. Again, in the same way as in C, yes. And also less than, greater than, less than or equal, greater than or equal, and so on. In the same way as other languages. We have only one difference in Python with comparison operators. Actually, this is a using of chains of expressions. For example, I can write something like 1 less than 2, or maybe 3, it doesn't matter, less than 4, maybe equals to 4, greater than 2, and so on. And this construction is calculated correctly. You can see how we can understand that, by the way. This character means comment, so I'm going to write a comment. It works like 1 less than 3 and 3 less than 4 and 4 equals 4 and so on. This is actually how it works. And sometimes it is useful. Sometimes we can make our code significantly more concise and more readable by using of these chains of conditions. So let's go on, and also I want to tell a few words about representation of integer. We can represent integer in different we can use binary representation, we can use hexadecimal representation, and so on. How to do that? This prefix allows us to use binary constant. Also, I can use hexadecimal value, something like ABC, and also we can use octal numbers, but maybe in C, if we want to use yes, if we want to use octal numbers, we should use prefix 0, something like that. And in Python 2, in previous version of Python, we also could use 0 as a prefix to say that this is a octal number, but there are a lot of problems with that. I can say that maybe almost of all people who doesn't use octal numbers just don't remember about this prefix, and as a result, if we use 0 as a prefix, our code becomes less readable and less understandable. To avoid this problem, in Python 3, this behavior was changed. So if we start integer number from 0, we will have just a syntax error. So Python just tells us that it's impossible to start integer with 0. For octal numbers, we can use something like that, this prefix, but I don't remember when I used octal numbers last time, so it's a very rare case where we really need them. But it's possible to do in such way. This is a set of constructions which we can use with integer numbers in Python. Then, sorry, please. The next numeric data type, it's a float numbers. We can just write something like 2.3, and it's going to be float number. The type function returns data type, which is float, and you can usually use float numbers to represent real numbers in our real world. But I want to say that it's not real numbers. It's just something like a model of real numbers. The problem is that our numbers are going to be converted to binary numbers, and for these binary numbers we have some limits for in length. As a result, we can have a little bit less accuracy, which we can expect in this case. Let me show you a classical example. We can do something like 0.1 plus 0.2, and we can see that it's not 0.3. And by the way, it's not a problem of on the problem of Python, because actually this behavior can be explained by the behavior of our CPU, our hardware. Our CPU uses standard IEEE 754, and this standard defines how float numbers are represented internally in the memory, and this representation is not accurate. As a result, we have such errors in calculations. What I want to say, we should remember about that, because as a result, we can use, for example, float numbers for engineering calculations, but we can't use float numbers for some maybe discrete values, something like some amount of money or something like that, because we will have a calculation error, and then later it can be a problem, because the result will not be correct. Also, we should remember that we never should compare float numbers for equality. If I write something like 0.1 plus 0.2 equals 0.3, it's obvious the result is going to be false. And imagine that you use such condition, for example, in the while loop. Yes, you want to continue while this condition is true. We will have endless loop in this case. So we never compare float numbers for equality. It's important. It's important to remember. If we really want to do that, we can compare them by some threshold. We can write something like, for example, maybe abs. This function returns absolute value, 0.1 plus 0.2 minus 0.3, for example, less than, I don't know, very, very small value. What is the problem? Minus. And you can see that the result is true. So in this case, we really can compare float numbers. Another way to do the same is to use a standard library. There is a math module in standard library, and math module has isClose function, which takes two arguments and return true or false depending on the accuracy which is used, which we want to have. So it's also the way to compare float numbers for equality, the correct way to do that. Okay. So any other arithmetic operators which we can use for integers, we also can use with floats. Addition, subtraction, division, multiplication, power, reminder, and that's all. Also, there is some different ways to use float constants. For example, if our integer part is 0, I can write something like that, 0.1, which means 0.1. Also, if my fractional part is 0, I can write something like 1 point, it means 1.0. And there is a exponential form for float numbers. I could write something like 1 to 3 times 10 in the power 3, for example. Is going to be such value. Like in other languages, so I think that it's understandable. We can use negative power and so on. So this is a set of examples where we can use float numbers. Also, maybe that's all about float. The fourth numeric data type, it's a complex data type. Maybe you remember from your math class that we can sometimes use complex numbers, and actually we can use imaginary unit, and which means a square root from -1. Yes, so if I write something like 1j times 1j, result is going to be -1. Actually, this is a complex number, and you can see what syntax is used in this case. Yeah, the data type for complex numbers is complex, and again, complex numbers can be used to represent to represent complex numbers, and all arithmetic operators can be also used for with complex numbers. Maybe that's all. That's all about numeric data types. Let me repeat that. Python has four built-in numeric data types. They are Boolean, integer, float, and complex. Maybe that's all. Also, let me tell a few words about standard library, because standard library also supports or provides some additional numeric data types which can be useful in some particular cases. For the first, standard library has decimal module, which allows us to represent our numbers in as decimal numbers. When we use decimal, this representation doesn't require conversion to binary. As a result, we will not have any problems with these conversions with binary representation, and have a better precision for calculations. Let me show you how it works. Let's just import decimal from standard library. Then we can create instance of decimal class. Later we are going to discuss this. I've been using classes and so on a little bit more, but now I'm just going to show you simple example. It's going to be 0.1. Please note that I use string representation here. If I just write 0.1 without quotes, in this case it's going to be just a float number, and immediately when I write a float number, Python interpreter will convert it to binary representation, and as a result we can lose our precision. So to avoid this, we are going to work with string representation. Then decimal dot decimal 0.2 as usual, and you can see that the result is 0.3. So now it works more correctly. For decimal objects, all arithmetic operators are also implemented, and we can use them as any other, just as regular numbers. Yes. If you want to, for example, to do something with some discrete values, for example, currency rate conversions, currency conversions, or something like that. In this case, it will be better to use decimal. Usually, it works better. Another example of using standard library for working with numbers, it's a fraction module. Fraction. I'm sorry. Let's Google fraction. Fractions. Sorry, fractions. So I don't use this module very often, so I don't even remember the name. But just to show you what we can do even with using standard library, I want to show you this module. So how I can use it? I can write something like fraction dot fractions, for example, 1/2. Then plus fractions dot fraction 1/3. Fractions again, sorry. And you can see that it works. So it means the result is something like something like that. Yes, it's a fraction. So also a very interesting module, and it allows us to make some calculations with fractions. And let me say this again, that we it's a very rare case when we really need that, but it's possible to do. Python has this representation in a standard library. Now we discussed all built-in numeric data types, and also some additional data types from standard library, which can be used in some other particular cases. Maybe that's enough for this first lecture, and maybe see you next time. Goodbye, colleagues.